All right, so let's talk about area of a trapezoid. So we've got the formula in the box on the notes, but I want to talk about what it means. So if you have a trapezoid, so let's take this blue trapezoid over here, and if you made two of those, so you can see here's the blue and here's the yellow, and you put them next to each other. So you doubled that blue trapezoid, you made an additional one, and you flipped it around. What you would get is you would get a parallelogram. And we know that the area of a parallelogram is base times height. So let's use that, okay, and let's ask ourselves, well, what's the height? Well, the height is going to be, the height of the trapezoid is going to be, so that would be this distance, is going to be the same height as the parallelogram. The base is going to be whatever the base is of the bottom base, so the longer side of the trapezoid, plus the smaller base on the trapezoid. If we add those together, so b plus u, that's going to give us the base of the parallelogram. So it's really going to be, so we're going to take, let's see, b plus u times height, okay? Now, if you look at the formula, there's a half there, and you might be asking yourself, well, where's the half come from? Well, we're only wanting the area of the blue blue trapezoid. We doubled it just to see how it would look if we made it into a parallelogram. So we're going to put a 1/2 here, just because we only want the area of the blue. We don't need the yellow. So instead of b plus u, I actually like to write this formula. So area of a trapezoid is, I usually write it like this: 1/2 times the height times base 1 plus base 2. The bases are always the parallel sides. Okay, so let's look at this trapezoid in example 10. So I'm going to write down 1/2 times the height. Now in this case, we're looking for the height and the base must be perpendicular. So base and height must be perpendicular. That's important. So I look for this right angle, okay, and so the height is 30. Notice it's not the length of the side, it's the height of the figure, 30, that forms the right angle with the base. One of the bases is 58, plus the other is 20. So we've got base 1 and base 2. So we don't actually even need these sides of 35.5. So when we put that all together, you can use your formula or your calculator if you want to. So when we put that all together in our calculator, you should get 1,170 square millimeters. All right, so let's look at example 11. So we've got area of a trapezoid again, so I'm going to write down the formula. 1/2 times the height times base 1 plus base 2. We know that the area is 48, so I'm going to put that in place of A. And then the bases are 4, whoops, there's a typo, and then 8. So I'm going to, and then we're finding the height. So I'm going to leave the height in, and I'm going to write 4 plus 8 for the bases. And then I'm going to come over here and simplify. So 48 equals 1/2 h times 12. I could multiply the 12 and the 1/2, because remember with multiplication, like if you have 2 times 3 times 4, it's the same thing as 2 times 4 times 3. You're allowed to rewrite it in a different order, which is the commutative property. So I'm going to take the 48 equals 6h. And then I'm going to divide both sides by 6, and I get h equals 8. And since the area was square inches, this is going to be inches. And then I would always double check and make sure it makes sense. So I'm going to come up here on top, and I'm just going to do 1/2 times the height of 8 times 4 plus 8. So 1/2 8 times 12, or 4 times 12 is 48, and that checks out. So just double check real quick. It doesn't take long. All right, so last but not least, we're going to talk about circles. So we've got a couple of different formulas here. So let's talk about area versus circumference. So the circumference of a circle, so if we draw a circle, is just the distance around. So if you were to take like a string, for example, and just measure, lay the string around the circle, and then take the string and flatten it out and measure it with a ruler, this would be the circumference. And there's two different formulas, either pi times the diameter or 2 pi r. So the radius is the distance from the center to the outside. The diameter would be the distance from one side to another going through the center. So it just depends on what you're given. Whereas the area of a circle is the not the distance, the area of the circle is the space inside a circle. Okay, and the formula for area of a circle is pi r squared. So I would add these to your formula sheets. So if you want to look, there's an interesting, if you want to check this out in the notes, there's a proof for the area formula for a circle. And if you actually take a circle and divide it into these pi-like sections, you can actually see that it makes what looks like a parallelogram. And we know that a parallelogram formula for area is just base times height. So if we find that the height of this parallelogram happens to be just the radius, so that's how big that is. So the base times height, the height is just the radius, and then the base is just half of the circumference, because like if you can see here, it's just the blue pieces, so that would be half of the circle. So 1/2 of the base, or 1/2 circumference times r, is where we start, and then we ask ourselves, well, what's the circumference? The circumference is 2 pi r. Well, 1/2 of 2 is just 1, and then I'm left with pi r squared. So that gives us the area of a circle. So let's look at number 12. So estimate the area and the circumference of the circle below. Oh, it looks like it. Okay, so if each of these is 1, you could estimate, maybe looks like, I don't know, this might be together, maybe that's 1, and these are together, almost 1 maybe, and this is just an estimate because we're just, and then maybe, I don't know, these are almost 1, so maybe we'll just call these 1, and we could do it this way and make it a high estimate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, but we know we added a little bit too much because we shouldn't have, some of these were missing, so I would say maybe, I don't know, take off a little bit, and maybe it's 13-ish, okay? And then let's go down here, and we're going to calculate the exact circumference and area of a circle. So instead of, here, let me just erase this here. So the circumference of a circle formula we can write down is 2 pi r, or pi times the diameter. So let's just use 2 pi r. So we know that the radius in this circle is 2. So 2 times pi times 2. Okay, and we could leave it as 4 pi, or you can multiply 4 times 3.1416, or use pi from your calculator. Either one will work. And then for area, we've got pi r squared, so you're just going to do pi times 2 squared, or 4 pi. And again, you can multiply 4 times 3.1416, or use the pi button in your calculator to multiply that out.